In this video, we're going to be discussing a design pattern known as the ViewHolder pattern. And the purpose of this pattern is to implement customized list views with the best possible performance. Now, a list view, as you know, allows you to scroll through a list of items. And in this particular app, we're using heavily customized list view items to display the name of each slideshow, to display a thumbnail image from each slideshow, and to display 3 buttons for each slideshow: a play button, an edit button, and a delete button as well. Now, because of that, when we're scrolling through the list, we don't want to have to create that customized set of views for every single possible item that will ever be displayed in the list view. We only want to have those views created for whatever number of list view items can be displayed at a given time on the screen, and then maybe 1 or 2 extras that have to do with the items that are currently scrolling onto or off of the screen respectively. So that's the purpose of the ViewHolder pattern, is basically to help you reuse existing list views, especially in the case of heavily customized list view items, so that you can then populate those customized views with information for the next item that's scrolling onto the screen, and not have to keep creating over and over again new list view items for display purposes. And that will help you manage your memory and also make your list view perform better as well. Now, to implement that pattern requires actually 2 different classes. One is the so-called view holder, and as its name implies, it holds onto a bunch of views. In our case, a text view for the name of the slideshow, an image view for one of the thumbnails in the slideshow, and 3 buttons for playing, editing, and deleting the slideshow respectively. And we're going to be creating objects of this view holder class to represent each of the list view items that is currently displayed on the screen, and probably an additional one for whatever item is about to scroll onto the screen as well. Now, our slideshow adapter class is the other key class in this view holder pattern discussion. The adapter for a list view populates the list view, and in our case we're creating a custom slideshow adapter that extends the predefined class array adapter, as you can see here from the android.widget package, and we're creating the array adapter for slideshow info objects, and of course those contain the information about the slideshows that we need to display in our slideshow activities list view. Now, for our slideshow adapter, we have 2 pieces of private data. We have a list of slideshow info objects called items, which, as you'll see down here, we initialize via the constructor. And we also have a layout inflator that we use to create the views that are displayed as list view items within the slideshow's list view. Now, for the slideshow adapter class, we have a constructor that receives the context in which the list view is displayed. Of course, this activity is going to be the context, and the list of slideshow info items. And we immediately call the superclass constructor, passing the context, in this case the second argument -1, and the third item, object rather, is the list of items that will be displayed in the list view by using this adapter. Now let's talk about that second argument of -1 for a moment. So what this actually represents is a resource ID for a text view where the text for that list view item will be displayed. Because we're going to be handling this ourselves programmatically later on, we pass the value -1 in this case. Now, at line 166, we store the list of items that was passed in as an argument to the constructor, and then at lines 167 and 168, we get the layout inflator that we'll be using to create the views for the individual list view items. Now, when you have a custom adapter like this one, you can override the getView method, which you can see here in starting at lines 172 and 173. And basically this is going to get called every time a new item needs to be displayed in the list view. And so this is going to be called for us automatically. And as you can see, this is going to receive three different pieces of information. An integer representing the position number in the list view, which corresponds directly to the position number in the list of slideshow info objects as well. So starting at index 0 of the list view is where the item from index 0 of our list of slideshow info objects will be displayed. So that position number is extremely important because there's a one-for-one mapping between position numbers in the list view and the data that will be displayed there. We receive a second item, which is a view called convert view, and basically this will be null if there is no reusable list view item for us to use at this moment, and it will be non-null if a list view item has scrolled off the screen and therefore now can be reused. So we'll see how we use that in a moment. And then we have a view group called parent, which is basically the parent list view object. Now at line 176, we create a reference variable called ViewHolder, and we then check at line 180 to see if the convert view parameter is equal to null. Now if that is equal to null, what that means to us is that there are no reusable list view items right now. For that reason, we will need to inflate the set of GUI controls that are going to be displayed in the new list view item. So of course when we first load up the slideshow activity, none of the list view items have ever been created before, so the first few times that this method getView gets called, we will certainly be creating the views for displaying information about each of the slideshows. But once we've fully populated that activities list view and we now start scrolling through it, as one item scrolls off the screen, a new item needs to come onto the screen, and at that point the list view mechanisms provided by Android will automatically start allowing us to recycle the list view items for efficiency purposes. So let's assume for the moment that convert view is null. In this case, we're going to inflate the layout for a given list view item, and that of course again contains a text view for the name of the slideshow, an image view for the thumbnail, and then 3 buttons as well for playing, editing, and deleting the slideshow. And now what we need to do is create an object to hold on to all of those pieces of GUI so that we can reuse them later on. And we call that a view holder. So we create a new view holder object. And in the view holder, we assign to each of its 5 variables the corresponding GUI component from the convert view that we just loaded up, that we just inflated. Right. So we now have created the view holder object, and the last piece that we need to do is for this so-called convert view object, the view that contains all the subviews, we set an object as its so-called tag. And what that does is it takes this view holder that we just created and associates it with the convert view, and we can use that later on for reuse of this view holder, as you'll see in the else part in just a moment here. Now if I hover over set tag, you'll see that set tag can receive any object as a tag. So basically you can associate any data you want as the so-called tag for a view. In our case, for a list view and individual list view items, we associate with each list view item its corresponding view holder, and we use that for reuse purposes. And that case comes up when convert view is not equal to null. In that case, we know we can reuse an existing list view item, and to do that, we assign to view holder the result of calling convert view.getTag, which gets the corresponding view holder object for the reusable list view item, and we have to cast that to type view holder here because getTag returns an object, but we know that we stored as the tag a view holder. Now whether we had to inflate the view from scratch and create the view holder, or we're reusing an existing view that has since scrolled off the screen, we now have a view holder object that we can use to help populate what's going to show up in the list view item. And to do that, we first go get the slideshow info object at the specified position. Remember that position is one of the arguments that's passed into the getView method automatically. And then for the current view holder, we go and set its name text views text to the name of the slideshow. We check to make sure that if the size of the slideshow is greater than 0 first, so that we can then get a thumbnail to display. And the way we do that is we go to the slideshow info object and get the image at index 0. So we're always going to use the first thumbnail as the one that's displayed in our slideshow list activity. And to load the image thumbnail, because that involves going out to the device's storage and getting information, we want to do that in a separate thread. So we have a load thumbnail task that we execute for that purpose, and we pass to that load thumbnail task the image view in which the thumbnail will be displayed. So the load thumbnail task will place the image into that image view for us, and we also give it the URI of the image that's going to be displayed. The URI.parse method takes the string representation of that item's location and turns it into a URI for the purpose of loading that image. And then finally, down below here at lines 216 through 225, for each of the buttons in our view holder, we set the tag on that button to the specific slideshow info object that would either be played, edited, or deleted. And we register the event listener for each of those buttons as well, for the play button, edit button, and delete button respectively. And then finally, at the end of the getView method, we return the convertView object, which is either a new object that we created because we needed a new one for the list items that were on the screen, or it's one that's being reused because it had previously scrolled off the screen.